Hey guys, welcome back. Naj Kazi here. In today's video, I'm going to discuss ACLs or access control lists. We're going to look at standard ACLs and extended ACLs. I'm going to talk about the difference between the two. I will also discuss named ACLs, and I'll wrap it all up with a real-world perspective on access control lists and some of the industry best practice designs that you should take into consideration when you're designing your ACLs. If you guys are interested in network security, consider ACLs as the first step into your security journey. It's very important that you understand ACLs because not only routers and switches, layer 3 switches, have ACLs on them, but also firewalls have ACLs. So it's very important that you get this concept so not only you become a great network engineer, but you also become a security-centric network engineer. With that said, I'm super pumped. Let's roll. Welcome to CCNA 200-301 course. Today I'm going to cover Section 5, Part 1 of the CCNA exam, Security Fundamentals. In particular, today we're going to discuss IPv4 ACLs. Here are the topics I plan on covering today. First, ACL Overview. Second, Standard ACLs. Third, Extended ACLs. Fourth, Named ACLs. And finally, I'll wrap it up with real-world perspective on ACLs. Let's go. Let's first cover ACL Overview. ACL stands for Access Control List. Each ACL contains multiple ACEs or access control entries. And you can also think of an access control entry as an ACL statement. So basically, ACL is a collection of statements or ACEs. ACL either permits or denies traffic. That's a very basic function of an ACL. So as you can see, the picture here, ACL is analogous to a coffee filter. So if you think of a coffee filter, what does it do? It traps the coffee grounds, but it allows the flow of liquid to go through. Similarly, ACLs filter traffic in our network. Each ACL is either applied inbound or outbound on an interface. ACLs actually do a lot more than permit or deny. And here are some of the things ACLs do. They filter ingress or egress traffic on an interface. They filter routing updates to and from neighboring routers. They are used in policy-based routing. They're used in network address translation. And when we use them in NAT, they're primarily used for not permitting or denying traffic, but they're used for matching traffic. In VPN, similar functionality as NAT. They're used for matching traffic. And QoS, same idea. We use ACLs to match traffic. You can either create a numbered ACL or a named ACL. There are three main types of ACL: standard ACL, extended ACL, and named ACL. Now, named ACL is not a new type of ACL. It's actually a spin on standard or extended ACL, and I'll get into those details momentarily, but just keep in mind that named ACL leverages either a standard or an extended ACL. Each ACL is processed top to bottom. Each access control entry can only have one set of conditions: either permit or deny. If no match is found, next ACE is processed in that list. If a match is found, that's it. Processing stops, no further ACEs are executed, and the whole idea here is first match logic. Meaning, if you think of an ACL as a sequence or a list of statements, as soon as the router finds the first match, it stops executing because that's it. It found the match and it's done. So for example, if you have 10 entries in your ACL If the first entry matches the packet, that's it. The 9 other statements in your ACL will be ignored because we have found our match. Now, order of statements is important in an ACL. The most specific or restrictive statements should be at the top of the ACL, and the least restrictive should be at the bottom, or the more general should be at the bottom of the ACL. Once again, the reason it's important is it's literally a list, and whatever is at the top of the list has the highest level of importance because that will get processed first. And the more general statements should be at the bottom of the list. Each ACL contains an implicit or invisible deny any at the bottom of the list. So this is a big gotcha. And one important thing to note is only one ACL can be applied per interface per direction. Now what that means is if you have an interface, you can have an inbound ACL and also an outbound ACL. But the inbound ACL is going to have to be different from the outbound ACL for obvious reasons, right? But you cannot have 2 different inbound access lists applied to a single interface or 2 different outbound access lists applied to a single interface. It doesn't work this way. You can only have a single ACL applied to an interface in each direction. Now let's shift our attention to standard ACLs. This type of ACL filters only based on the source address and the packet header. What do I mean by that? Let me explain. So if this right here is a packet, and let's say this right here is the payload, which is the data, and right here we'll have source IP, and in the header we'll also have destination IP. Now, what ends up happening is in this scenario, when we apply an ACL, the ACL will only pay attention to this field, the source IP field. And that's exactly what I mean right here when I say that ACLs, the standard ACLs, only pay attention to the source address. It lacks granularity. Because standard ACLs either permit or deny traffic at a protocol level, at IP level, they don't really have the ability to give you a lot of granularity. Standard ACL number ranges start from 1, go all the way up to 99, and there's another expanded range that starts from 1300, goes all the way up to 1999. Now, from a best practice design perspective, you should place standard ACL as close to the destination as possible. And I'll walk you through the design and show you why that is important. And finally, here's the CLI syntax. So if you're on a router, we'll type in the command access-list space, and then we'll choose 1 through 99 or 1300 through 1999. And then we'll say either permit or deny, and then we'll have the matching parameters. So the first step is the creation of the access list. Once the access list has been created, the next step is that we go to the interface and we apply it to the interface. So in this scenario here, we're saying interface fast00 IP space access-group space out space 1, which happens to be our ACL number. Now, always remember, it's a 2-part thing. Part 1, you have to create an access list, and part 2 is you have to apply the access list to the interface. If you don't apply it to the interface, access list is not going to do anything. It's just going to sit there without doing anything. Now let's quickly talk through the wildcard mask, because ACLs require a wildcard mask. Now, wildcard mask can block a range of addresses or a whole network with just one statement. Zeros indicate which part of an IP address must match the ACL. Ones indicate which part of an IP address doesn't have to specifically match the ACL. Use the host parameter in place of 0000 wildcard, or use the any parameter in place of 255.255.255.255 wildcard. And here's a quick chart. So if you want to match the entire IP address exactly, then you're going to have to say 0.0.0.0. And if you want to match anything, then you'll say 255.255.255.255 at the very bottom, and that means all 32 bits can be matched because those are don't care bits. Now let me do quick whiteboarding to explain wildcard mask compared to the standard subnet mask that we are used to. So if you look at a subnet mask, let's say a /8 subnet mask, what do we have? We have 255.0.0.0. If we have /16, that's 255.255.0.0. And if we have /24, that is 255.255.255.0. Now, what happens in a wildcard mask is, by the way, in one of the earlier videos, I covered the wildcard mask, but consider this a review, and review never hurts. So I decided to give it a shot so you guys can solidify this concept in your head. So to the left is the subnet mask, but here, let's do the wildcard mask, or WM. So the opposite, so remember, wildcard mask is the mirror opposite of a subnet mask. So mirror opposite would mean we'll go from /8 being 255.0.0.0 to 0.0.0.255. So it's literally the opposite. In this case, for /16, it's 0.0.255.255. And in the case of /24, it's 0.0.0.255. And like I said, this is the mirror opposite of the subnet mask, the wildcard mask. Now, you may be thinking, how about some tricky scenarios? Let me give you a couple of tricky scenarios. How about /12? So let's first look at the subnet mask. So that's 255 dot. Now, 255 is 8 bits, right? So an IP address is divided into 32 bits, which means it's 8 bits plus 8 bits plus 8 bits plus 8 bits. So each octet happens to be 8 bits, right? So in /12, the first octet is 255. What about the second octet? Well, here, what ends up happening is, if you guys remember the handy dandy binary conversion chart, 1, 2, 4, 8, 16, 32, 64, 128. Let's see what 12 gives us. So that's 4 bits. 1, 2, 3, 4. That gives us a 240. If you were to add 128 plus 64 plus 32 plus 16, that gives us a value of 240. So we'll place 240 here, and then we'll do 0.0.0. Now that's a subnet mask. Now, how do we come up with a wildcard mask from this subnet mask? So what's going to end up happening is 255 is going to turn into 0. And here's the trick. What you will do to convert 240 into wildcard mask would be, we'll write down 255 minus 240. What does that give us? It gives us a value of 15. We'll place 15 right here, and then we'll go 255.255. So remember, in wildcard mask, 0 means I care, and 255 means I don't care in terms of bits. So now that you have a good understanding of wildcard masks, I think you guys are ready to jump on a command line. But let's be patient for one more second here so I can explain to you the lab topology. In this topology, we have Bob and Leah on our LAN segment of 10.1.1.0/24. That's to the left of our internal gateway router right here. That's what IGW stands for. And to the right of IGW, we have a switch, and that switch has an accounting server plugged in, and that switch also plugs into the LAN port of our Internet Edge router. That's what iEdge stands for. And then to the right of Internet Edge is an internet circuit coming in from our service provider that is allowing us internet access. This is how our topology is set up. And I'm going to use the same topology today to explain standard ACLs, extended ACLs, and named ACLs, because that makes it easier to constantly look at the same topology and refer back to it. Now that we have looked at the topology, let's look at the first lab. So here's the first lab. So we have a security policy in our network that suggests that Leah should be denied access to the accounting server on the LAN, and Bob should be denied access to the www server on the internet. Now, one more concept before jumping on the command line that I want you to understand is we have these requirements here in front of us. Where do we apply the ACL and in which direction? And let me explain. So the first statement says block Leah from accounting. So Leah's down here and accounting server is up here, right? How do we block Leah from accessing the accounting server? Now, where can we place ACLs? Well, there's only two places where we can have ACLs in our network. Either the internal gateway router, or IGW, or the Internet Edge, or iEdge router. Now, accounting server happens to be closer to the internal gateway. So what we'll do is we'll have to apply an ACL on the internal gateway router. And by the way, this is a layer 2 switch, so we can't apply ACLs here. Okay, just to clarify. So now the next question is which interface? Because remember, ACL is not applied to the entire router. ACL is applied to the interface. Either we can apply it on fast 1/0 or fast 0/0. Where should we apply this ACL? Now, let's think back. If you guys recall, when it comes to standard access lists, the recommendation from Cisco is that we place the standard ACL as close to the destination as possible so we don't block traffic. Now, here's what it means. If I were to apply this access list on fast Ethernet 1/0 in the inbound direction, what's going to end up happening is because standard ACLs only match on the source, Leah's IP will be blocked from accessing anything on the entire network, to the point that Leah won't even be able to ping Bob's PC. It's going to be completely cut off from all access to the network because we're applying this ACL really close to the source, and we don't want to do that. We have to apply it as close to the destination as possible. So through the power of deduction, we have realized that we can't apply it here, so we're going to have to apply it on fast Ethernet 0/0. Now, another thing that's important is where should we apply it? In the inbound direction or the outbound direction on fast 0/0? Well, one thing for you to keep in mind is as Leah traffic comes into the router, it comes into fast Ethernet 1/0. But the traffic leaves, goes out on interface fast Ethernet 0/0. So that means if we were to apply this ACL, it's going to have to be applied on fast Ethernet 0/0 in the outbound direction, because that's the flow of traffic in our network. If we applied it in the inbound direction, it's not going to work because Leah sits on fast Ethernet 1/0 side, and the traffic is received on that interface and then sent out on the interface to the right, which is fast Ethernet 0/0. So this is very important, and the reason I'm spending some time here, guys, is because when I was new, this used to trip me up all the time. And I want to make sure it's crystal clear in your head how you're going to think through when you have a problem in front of you, how you're going to think through it and come up with a strategy to apply the ACL. Now, how about the second item in our security policy? Deny Bob from accessing the web server on the internet. Now, Bob happens to be right here on the left, and the web server happens to be all the way to the right on the internet. Now, to block Bob, where should we do that? On the IGW or iEdge? Well, remember, we have to go as close to the destination as possible, right? So we're going to actually have to apply Bob's access list on the iEdge router. And once again, which direction should we apply it in? If we do it in the inbound direction on fast 00, we may be cutting off Bob's access too soon. So what we need to do is actually apply it on fast Ethernet 1/0 in the outbound direction as the traffic leaves the internet edge router toward the internet. And that is essentially as close to the destination as possible based on the best practice recommendation. Now I believe we are ready to jump on the CLI. I'm on Bob's PC. It's actually a router, but I'm pretending to be a PC. Let's see if I can go ahead and ping the web server all the way through the internet. So I'll do ping 80.1.1.1. And sure enough, Bob, who happens to be on the leftmost side of our network, is able to ping a web server that happens to be on the rightmost side of our diagram here, which means the connectivity in the middle is all working for us. And let's run the same test on Leah's PC and see how that goes. And once again, we're successful. So both Bob and Leah have full connectivity all the way through our network. Now, let's look at our security policy. It says first, we need to deny Leah from accessing the accounting server. So, as discussed earlier, I'm going to go to IGW, our internal gateway router, and I'm going to create an access list. So I'm going to type in configure terminal, and I'm going to create an access list. Here's how you create an access list. Access-list, and we have a ton of options here. Because this is a standard ACL, we're going to focus on standard ACL. We'll do access list 1 space question mark, and now we have the ability to either deny or permit. We're going to go ahead and deny access, and the source in this case happens to be Leah's PC, so we're going to type in 10.1.1.101, and we'll type in our wildcard mask. And because we need to match every single octet in the source, we're going to have to type in a wildcard mask of 0.0.0.0. That means match everything exactly. And that's it. Because remember, this is a standard ACL. So the only thing we can filter on is the source IP, which happens to be Leah's PC IP. So when I do that, I'm done creating my access list. The next thing we need to do is go ahead and apply the access list. Now remember, we are supposed to apply this access list as close to the destination as possible. So we're going to go to interface fast Ethernet 0/0 and type in IP space access hyphen group and type in the number of our access list, which happens to be access list 1, and then the direction. Is it going to be inbound or outbound? Well, I articulated earlier, because fast Ethernet 00 is where the traffic is going to be going out of from Leah's perspective, we're going to have to apply it in the outbound direction. And that's it. At this point, let me go back to Leah's PC here and see if I can ping the accounting server 10.2.2.99. And sure enough, I'm unable to do so. All U's mean unreachable. Now let's go back to the internal gateway router or IGW and type in do show access list command to display all the access lists on this router. There is an issue with this access list. Can you spot what the issue is? If you want to pause this video for a moment, go right ahead. See if you can spot the issue. Well, here's the challenge. We don't have a permit any statement at the bottom of this access list, and that is necessary. So what we should do is go back to global config mode, type in access list 1 permit any. Just to get some practice, let's go ahead and blow up or remove the previous access list. So we'll type in no access list 1. And what we should do now is type in access list 1 deny, and we can type in host. So this is a variation of what we did earlier. Remember before I typed in the exact IP address of Leah's PC and then a wildcard mask of 0.0.0.0? That's the long method. The short method is we choose the keyword host and we type in 10.1.1.101 and hit enter. And then to complete this access list, we should type in access list 1 permit any. And that should complete our access list. Now we can go ahead and type in show access list, and here we are. Now our access list is created properly. Now let's go back to Leah and see if we can get to the accounting server 10.2.2.99. And we're unable to do so. The way we can verify that is by coming to the access list and typing in the command do show access list. You see the difference between before and after. Now what you will see is when I look at show access list, right in front of the statement that actually matched, you'll see how many packets actually matched this access list. So this is a quick troubleshooting and verification mechanism to ensure that your access list is working the way you intended it to work. So that's great. Now let's look at statement number 2, block Bob from accessing the web server. Now what we need to do is we should go to the Internet Edge router, go to global config mode and create this ACL for Bob. So we'll type in access list 1 deny host Bob's PC, and then we'll type in access list 1 permit any, because there's an implicit deny at the end of every single access list. It's invisible, you cannot see it, but it's a big gotcha, so keep that in mind. We'll go to interface fast Ethernet 1/0, we'll type in IP access -group 1, and we'll do it in the outbound direction. And that should do it. So if I go to Bob's PC now and try to ping the web server, we're getting unreachables. So our traffic is being denied. But if I were to ping, for example, 10.2.2.1, which happens to be the LAN interface of the iEdge router, up until that point, I'm able to successfully reach various devices within my network. Now let's quickly go back to Leah and see if we can ping the internet server. Leah is unable to reach the web server on the internet. Why is that? Leah should have access to the web server. We only intended to deny Leah's access to the accounting server. Well, once again, guys, standard access lists are in real world, typically they're troublesome because you see what's happening here is we applied the access list on this interface, Fast Ethernet 00 on IGW right here in the outbound direction. So what that means is Leah's access is not only cut off to the accounting server, but her access is cut off from all other devices on the network. That includes this link right here. That includes this link right here on the WAN, including the web server on the internet or any other device on the internet. Leah is essentially cut off from the entire network. The only device Leah can reach is Bob's network, or basically that LAN segment that it's attached to, but it is unable to communicate with any other subnet because of the access list. And that's why standard access list is a bad idea. And this is a perfect segue into the extended ACL. Now let's quickly shift our attention to extended ACLs. This type of ACL filters on the following 5 parameters: source IP address, destination IP address, source port, destination port, and protocol. Combined together, we call that a 5-tuple. And this makes extended ACLs highly granular because we are able to match on so many different fields within the IP packet header. Here are the extended ACL number ranges. We go from 100 through 199, and the expanded range goes from 2000 through 2699. Now, best practice design suggests that we place the extended ACL as close to the source as possible. This is the opposite recommendation compared to the standard ACLs. And it's for a good reason. Because we have so much granularity, we have the ability and flexibility to apply extended ACL as close to the source as possible. And here's the CLI syntax. So we go to global config mode, type in access-list space, we pick a number, then we say either permit or deny, and then we have matching parameters. Here's an extended ACL lab. So in this lab, what we're going to do is we're going to deny Bob from accessing the accounting server. Then what we'll do is we'll block Leah from accessing Telnet on both routers. We'll block both Bob and Leah from pinging the WAN link. We'll then perform edge filtering, denying RFC19 address space from the internet, and I'll explain why. And finally, we'll allow all other traffic. So that is our security policy. So let's get cracking on command line. Here I am on CLI. This time around, we're going to apply extended ACLs. So what I'm going to do is, first of all, I'm going to go ahead and delete the standard ACL we have. So I'll do show access-list and see the access list that I have that I need to go ahead and delete. Also, I'm going to quickly do show run and do section 00 to look at Ethernet 00. That's where I have the ACL applied. So I'm going to go to global config mode. First, I'm going to go ahead and delete the access list. So I'll do no access list 1. It's gone. Next thing I need to do is go under the interface and type in no IP access group 1 out. And now the access list is completely deleted and has been disabled on the interface. Now, what I would like to do next is create an extended ACL that allows me to create the security policy. Now, if you were to pay attention to the security policy, what we'll notice is that lines 1, 2, and 3 can be combined together. And because you're supposed to apply the extended ACL as close to the source as possible, we can combine these three items in our security policy and apply them on the IGW. So let's go ahead and get cracking. So the first thing we'll do is we'll type in access-list space question mark. Because this is an extended access list, we can start at 100. So I'll start at 100. And then we'll say deny because we're blocking Bob. And what exactly are we blocking? Now in this case, we're blocking Bob from accessing the accounting server to begin with. So we'll say IP, and then we'll say host 10.1.1.100, and we're denying access to host 10.2.2.99, and that's it. That's the first item in our security policy. Now let's go ahead and cover the next item. Okay, now this one is going to be slightly different because we're denying telnet on both routers, which means we need to match on a TCP port. So here we're going to say TCP host 10.1.1.101, and I'll say host, and I'm going to basically have to cover different interfaces because Leah, if you think about it, Leah can telnet into IGW either on the LAN segment, or it can use the 10.2.2.2 address, or she can use the 10.2.2.1 address to get into the Internet Edge router, or she can use 64.13.232.137 address to be able to telnet. So we're going to have to block all those addresses. So to cover that, I'll go left to right. So I'll say host 10.1.1.1. That's the fast Ethernet 1/0 interface on IGW. And I'll say equal telnet is port 23. Next, I'll say access list 100 deny TCP host 10.1.1.101 to host 10.2.2.2 equal 23. The next statement is going to be deny TCP host 10.1.101 host 10.2.2.1 equal 23. And finally, access-list 100 deny TCP host 10.1.1.101 host 64.13.232.137 equal 23. So these four statements should completely block Leah from accessing either of the routers, from using any of the IPs that are configured. So that's statement number 2 on our security policy. What does statement number 3 say? It says block both Bob and Leah from pinging the WAN link. So to do so, we're going to type in access-list 100 deny. And this time around, we're going to say ICMP. And we're going to say host. Let's start off with Bob first, 10.1.1.100. And we're going to type in host 64.13.232.136 or 137. Hit enter. And I'll type in access list 100 deny ICMP host 10.1.1.101 to block Leah from being able to ping the WAN link. So I think at this point, our access list covers the top 3 items on our security policy. And if you remember, the last thing we always want to have is permit IP any. So now let's go ahead and do show access list to see how our access list looks like. That's a pretty decent size access list. And as you can see, we have 8 entries in our access list. The first entry is denying Bob from accessing the accounting server. Entry 2 through 5 is blocking Leah from telnetting into either of the routers. Entry number 6 is blocking Bob from being able to ping the Internet Edge WAN link, and statement number 7 is blocking Leah from accessing the internet edge WAN link. And then we have permit IP any. So at this point, the access list is created. Now we need to go ahead and apply the access list. Now in this scenario, because we apply this as close to the source as possible, we're going to apply this access list on fast Ethernet 1/0 and IGW, which happens to be directly connected to that LAN segment where Bob and Leah are. Now that we have created our access list, let's go ahead and apply it to fast Ethernet 1/0, and we'll say IP access group 100 in the inbound direction. Let's go back to Bob, and the very first thing we want to do is ping the web server on the internet. Make sure we have connectivity all the way through. And sure enough, we can ping all the way through, which means we shouldn't have any issues in between. So that's good. Now, let's go step by step. So our security policy said Bob should be denied access to the accounting server. Let's see if that's the case. Let's ping 10.2.2.99. Sure enough, the accounting server is unreachable for Bob. Now, how about the other IPs in the same subnet where the accounting server is? For example, 10.2.2.2 on IGW or 10.2.2.1 on iEdge. Let's see if Bob can ping those. 10.2.2.2, sure enough, looks good. 10.2.2.1, sure enough. So as you can see, it's very precise, the extended ACL. It only blocked access to the accounting server, yet on the same subnet, Bob is able to reach other devices. So that's beautiful. Standard access list doesn't allow us to do that. Now let's go to Leah and see if Leah is able to ping the web server on the internet all the way through. And let's see now if she can telnet into 10.1.1.1. Nope. Destination unreachable. It was actually denied. How about 10.2.2.2? Nope. How about 10.2.2.1? Nope. How about 64.13.232.137? Nope. Leah was denied access to telnet on either of these routers. That is beautiful. So our security policy is looking pretty solid. And finally, neither Leah nor Bob should be able to ping the WAN link. So let's do ping 64.13.232.137. It says unreachable on Leah's PC. How about Bob? Ping 64.13.232.137. It says unreachable again. Now let's go ahead and check out that ACL that we created on IGW. Let's do show access list and look at all these beautiful matches. Don't you love that? Pretty much every single item on our list, there is a match, which means our ACL is working beautifully, just the way we intended it to work. Don't you love it when all your hard work pays off? That's awesome. So at this point, we have taken care of the first 3 items. Now, item number 4 on our security policy is a unique one. It says perform edge filtering, denying RFC 1918 address space from the internet. So what does that mean? Let me explain what that means. So this is part of what we call an infrastructure ACL. Okay, you should Google it and you'll find out what that is. Okay, it's you'll find a link to a Cisco document that gives you exactly what you need to configure. But this right here is a subset of that infrastructure ACL. So what that means is, because we have RFC 1918 addresses configured on our LAN, right now we're only using the 10 subnet, but nothing is stopping us from using the 172 space or the 192, 168 space, right? What we should not expect is any of the RFC 19 I-18 private IP address space to be showing up from the internet. Because if that traffic is coming from the internet with private space, it means the traffic is being spoofed, and most likely a bad actor or a hacker is trying to break into our network. So by applying an edge filtering at the edge of our network, which in this case would be the internet edge router, we can create what's called anti-spoofing on our network, and it will block private IP addresses from showing off the internet. Now, we should allow our private IPs to go out to the internet, but not the other way around. Traffic shouldn't come back from the internet with the source of private IP address space, because that would be a security violation. So let's go ahead and configure that on the internet edge. So here I am on the internet edge router. I'm going to go to global config mode, and I'm going to create an extended ACL access list 100. I'm going to say deny, and let's get started with the first entry in our ACL. This would be deny IP 10.0.0.0, which is 0.255.255.255. That's a wildcard mask, and the destination would be any. The next entry in our access list will be deny IP 172.16.0.0, and with a wildcard mask of 0.15.255.255 space any. And the third entry will be access list 100, deny IP 192.168.0.0, 0.0.255.255, any. And the final statement in our ACL will be access list 100, permit IP any. That's it. We have now created our access list. Well, where should we apply it? As always, as close to the source as possible. So I'm going to go ahead and type in internet fast 00, and I'm going to say IP access list or access group 100 in. As a matter of fact, that's not going to work. It should actually be the other way around. So I'm going to go ahead and remove it. I'm going to exit, go to interface fast ethernet 1/0, and type in IP access group 100 in. So basically, we should be expecting this traffic to be coming from the internet. So we have to apply it to the internet facing interface, which happens to be fast ethernet 1/0. Okay, so that's it. At this point, we have applied our access list. Let's do show access list, and it's right here. Thanks for sticking around. By the way, there's a lot more to this video than what you have seen. In order to watch the entire video, you're gonna have to be a little patient, because I'm working on designing an entire CCNA course. I'm gonna do an official launch in the next couple of months, but until then, I'm gonna keep putting little nuggets of the CCNA exam out there on my YouTube channel until the course is ready to be published. Hope you enjoyed today's video. If you did, give me a thumbs up, hit subscribe, and I'll see you in the next video.